Welcome all of you dear students. This is the simplest and easiest way of teaching learning process in our most popular YouTube channel. Physics Make It Simple by Dr. Rajendra Kobarne, now working as a principal in Lokanete Dr. Bala Saheb Vikhe Patil Padma Bhushan Awardee, Pravara Rural Education Societies Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. Dear students, as long as 12th Science is concerned, we are discussing the chapter Oscillations, and this is the lecture number 8, and in this lecture we have to learn graphical representation of SHM when particle starts from extreme position. Remember well. So in the lecture number 7, we have learned more detail regarding graphical representation of SHM when particle starts from mean position. Now the same article, the similar article we have to learn, only the difference is that when the particle starts from extreme position. Let us start. We will have to find the three equations at first, that is displacement, velocity and acceleration. Remember well dear students, when the particle starts from extreme position, at that time initial phase angle phi, or we call it as epoch, the value of phi is equal to pi by 2 radian or 90 degree. And so that I have written the first sentence, when the particle starts from extreme position, then initial phase angle phi is equal to pi by 2 radian or 90 degree. When the particle starts from mean position, at that time the value of phi is equal to 0 degree, that we have already know. The general equation of displacement of SHM, that we are well familiar, that is x is equal to capital A sine of omega t plus phi. Remember well, capital A stands for amplitude of SHM, while small a stands for acceleration in SHM. Here is a capital A. The general equation is x is equal to capital A sine of omega t plus 90 degree, because the value of phi is equal to 90 degree or pi by 2 radian, since the particle starts from extreme position. And we know sine of omega t plus 90 degree is equal to cos omega t, so that our first equation got is x is equal to capital A cos of omega t. This is equation 1. This x stands for displacement of the particle in SHM. Okay. From the displacement, we have to find the formula of velocity. What is velocity? Velocity is nothing but the rate of change of displacement. So here take a derivative of x with respect to t, we get velocity v is equal to dx by dt is equal to capital A is constant, and derivative of cos omega t is minus sin omega t, again derivative of omega t with respect to t is equal to omega, and so we get minus omega sin omega t. Then this a omega minus sin is taken outside, so minus a omega sin omega t. This is equation number 2, and this is the equation of velocity of a particle in SHM. So from velocity we have to find the equation of acceleration. We know acceleration is denoted by small a, and acceleration is nothing but the rate of change of velocity, and so that we have to take a derivative of velocity with respect to time. We get acceleration a is equal to dv by dt. Take double derivative of dx by dt. We get what? d2x by dt square is equal to, here minus a omega is constant, that I have written here minus a omega. Derivative of sin omega t is cos of omega t. Again derivative of omega t with respect to t is omega. So derivative we get is omega cos omega t. Then multiplying this omega with omega, we get minus a omega square cos of omega t. This is equation 3. In this way we got three equations, that is displacement, velocity and acceleration, as shown in the figure. So after getting the three equations, now we will have to prepare an observation table. Many of the students are feeling more difficult task to prepare an observation table, but it is a very simple. How it is simple, let us see. So the first row is denoted by time t. How we can remember this? Suppose we can remember this. T stands for nt by 4. T stands for nt by 4, where n is equal to 0, 1, 2 and so on. Put n is equal to 0 at first. 0 t by 4, we get 0. 1 t by 4, we get t by 4. Put n is equal to 2. 2 t by 4, we get t by 2. Put n is equal to 3. 3 t by 4 as it is. Put n is equal to 4. 4 t by 4. 4 get cancelled. You get t. And in this way, 5 t by 4, 3 t by 2. We can extend this row. We can extend this row, but we have taken up to 3 t by 2. Okay. In this way, we can easily write this first row regarding time by remembering this hint. Then how we can write the value of omega t? Omega t stands for n pi by 2. Remember this formula. Omega t stands for n pi by 2. This is a sort of teaching model. This is a sort of teaching model to remember these first two rows. Put n is equal to 1. Put n is equal to 0 at first. 0 pi by 2, we will get 0. 1 pi by 2, we get pi by 2. 2 pi by 2, 2 get cancelled, we get pi. 3 pi by 2, we get this as it is. And in this way, 2 pi, 5 pi by 2 and 3 pi. In this way, first two rows we can easily write by making use of these two formulae, by making use of these two hints. That is, small t is equal to nt by 4 and omega t is equal to n pi by 2. Now we have to find the value of displacement with respect to every value of omega t. How we can prepare, how we can write this row of displacement? Let us write the formula of displacement at first. What is the formula of displacement? Displacement x is equal to, we got is a cos omega t. A cos omega t. See here, put the value of omega t is equal to 0. Put the value of omega t is equal to 0. Cos 0 is equal to 1. And 1 into a we get is 1. This is the equation, capital A. This is the value, capital A. Put omega t is equal to pi by 2. Put omega t is equal to pi by 2. Cos of pi by 2 is equal to 0. 0 into a we get is 0. Put omega t is equal to pi. Put pi here. Cos of pi is equal to minus 1. Then we get minus 1 into a, we get minus a. In this way, a, 0, minus a, then serially we get, of course, 0, a, 0, minus a. In this way, we prepare the values of displacement for every omega t. For every omega t. In this way, we can calculate the value of displacement like this. Then write the equation of velocity. Write the equation of velocity. The equation of velocity is, we can write here, equation of velocity. Write the equation of velocity. Equation of velocity we get is, what is the equation of velocity? V is equal to minus a omega sin omega t. This is the equation of velocity. Then put omega t is equal to 0 here. Sin 0 is equal to 0. 0 into minus a omega is equal to 0. Then put omega t is equal to pi by 2. Sin pi by 2. Omega t is equal to pi by 2. Sin pi by 2 is equal to 1. 1 into minus a omega, we get minus a omega. Put omega t is equal to pi. Sin pi is equal to 0. 0 into any term, we get 0. So in this way, we get 0 minus a omega 0. The next value must be a omega 0 minus a omega 0, like this. In this way, we find the values of velocity for every omega t. For every omega t. we can find the value of velocity. Now the acceleration is remaining. Write down the formula of acceleration here. Formula of acceleration. What is the formula of acceleration? The formula of acceleration is A is equal to minus A omega square cos omega t. Put omega t is equal to 0 first. Omega t is equal to 0. Cos 0 is equal to 1. 1 into minus A omega square. We get minus A omega square. Put omega t is equal to pi by 2. Cos of pi by 2 is equal to 0. 0 into any term is 0 here. Put omega t is equal to pi. Omega t is equal to pi. Cos pi is equal to minus 1. Minus 1 into minus A omega square. We get plus A omega square. In this way we get what? Minus A omega square 0 plus A omega square. Of course we get the next value 0 minus A omega square 0 A omega square. In this way we prepare observation table in a very simplest way, because name of our channel is Physics Make It Simple, and by making use of the values of displacement, velocity and acceleration, we have to draw a graph. This graph is drawn like this. We can write pi by 2 pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, and omega t is the x-axis. Instead of writing pi by 2 pi, 3 pi by 2, we can also write like this: 0, t by 4, t by 2, 3t by 4. So instead of pi by 2 we can write t by 4. Instead of pi we can write t by 2. This may write instead of this, but I have written the value of omega t. Then see here, displacement. When omega t is equal to 0, displacement is capital A. When omega t is equal to 0, the displacement is capital A. We get value here. Okay. When omega t is equal to pi by 2, when omega t is equal to pi by 2, displacement is 0. Here, displacement is 0. Then next one, when omega t is equal to pi, displacement is minus A, pi minus A below, like this. In this way, when omega t is equal to 3 pi by 2, we get displacement 0 here. So the graph is like this. The graph is like this. The next point will come here. The next point will come here. The next point will come here. And the nature of the graph is like this. The nature of the graph is like this. See here, this is the nature of the graph. This is the nature of the graph. The nature of the graph is like this. This is the graph of displacement. Then velocity. Omega t is equal to 0, at that time velocity is 0. Omega t is equal to 0, at that time velocity is 0. Okay. When omega t is pi by 2, at that time velocity is minus A omega. Pi by 2, velocity is minus A omega. Here like this. This plus A and minus A are the extreme values of displacement. Plus A omega and minus A omega are the extreme values of velocity. Then pi by 2. Pi. Omega t is equal to pi. At that time velocity is 0. The value will come here. The next, when omega t is equal to 3 pi by 2, we get velocity A omega. A omega is here like this. So the nature of the graph 3 pi by 2, 3 pi by 2, 3 pi by 2, we get value here. So in this way the graph is like this. The graph is like this. The next point should like this. The next point is here. The next point is here. And the nature of the graph is like this. See here. This is the nature of the graph. This is the nature of the graph. This is the nature of the graph. So this is the nature of the graph of velocity. Then acceleration. See here. When omega t is equal to 0, acceleration is minus A omega square. When omega t is equal to 0, acceleration is minus A omega square. Here we get. When omega t is equal to pi by 2, acceleration is 0. The point is here. 0 acceleration like this. When it is pi, at that time acceleration is A omega square. So plus A omega square and minus A omega square are the extreme values of acceleration. So the next point we get 3 pi by 2. When 3 pi by 2, acceleration is 0. The point is here. So in this way the point we get is, the point should get like this. The next point should be here. The next point should be here. The next point should be here. And the nature of the graph is like this. See here. The nature of the graph is like this. Okay, like this. So this is all about graphs of displacement, velocity and acceleration. And from this graph we will have to prepare, we will have to write, we will have to make remarks or conclusions. The conclusion number 1, all the curves are periodic in function. So what is meant by periodic in function? Because all the curves repeat itself after a phase 2 pi. See here, this is the initial point, this is the final point. This complete one curve here from this to this, and we get phase interval 2 pi. See here, this is a curve, one curve during the phase interval 2 pi. This is a one curve here like this here during a phase interval 2 pi. So all the curves repeats itself after a phase interval 2 pi radian. So two conclusions we have already written, first two conclusions. Number 1, what is the first conclusion? Displacement, velocity and acceleration are periodic in nature. And the second one, all the curves repeats itself after a phase interval 2 pi. So these are the two conclusions that I have written here first. Then the next conclusion is, when the curve starts from extreme position, either plus a or minus a, either plus a omega or minus a omega, either plus a omega square or minus a omega square, if the graph starts from extreme position, that curves are cosine in nature. And the curve which starts from mean position, only the velocity curve starts from mean position, from 0. So velocity time curve is sine function, while displacement starts from extreme and acceleration also starts from negative extreme. So displacement time curve and acceleration time curve are cosine curve, while velocity curve is sine curve. This is the third conclusion. Then we will have to write three conclusions. What is the phase difference between displacement and velocity? What is the phase difference between velocity and acceleration? What is the phase difference between displacement and acceleration? How we can calculate the phase difference? The simplest way is like this. See here, displacement touches the x-axis at first during pi by 2. Displacement touches the x-axis at first during phase pi by 2. Velocity touches the x-axis at first during pi. Difference between 2, pi minus pi by 2, we get pi by 2. So that phase difference between displacement and velocity is pi by 2. Then calculate the phase difference between velocity and acceleration. Velocity touches the x-axis at first during pi. Acceleration touches the x-axis at first during pi by 2. Again difference between 2 is pi minus pi by 2 is pi by 2. So phase difference between velocity and acceleration is also pi by 2. Then observe the graphs of displacement and acceleration. At the time of trough of displacement, there is a crest of acceleration. At the time of crest of displacement, there is a trough of acceleration. That means displacement and acceleration are exactly out of phase. They are exactly opposite. Nature is opposite. See here, there is trough, here is crest, like this. It starts from positive extreme, it starts from negative extreme. Here is crest, here is trough. Here is crest, here is trough. Here is trough, here is crest. That means two graphs are exactly opposite. And so that phase difference between displacement and acceleration is 180 degree or pi radian. So these are the 6 conclusions we can easily write by observing the graph very carefully. So in this way we prepare the question, explain the graphical representation of SHM when particle starts from extreme position. Remember well dear students, prepare the 3 equations at first, From 3 equations, prepare observation table. From observation table, draw graph, and from the graph, write the conclusion. In this way, this is the very simplest and easiest way of teaching learning process. In our YouTube channel, Physics Make It Simple. So, we will stop here and we'll meet again by taking next lecture. Goodbye.